Welcome. In today's session, we will explore resource scaling and load balancing, specifically in Azure environment. These are two of the essential features for ensuring that your resources will perform optimally and are always available, regardless of the demand or the spike in demand. We'll cover how to automatically scale resources, configure load balancing to improve performance and availability, and how these capabilities can work together to enhance your cloud environment. So let's get started. Now, the first topic is how to scale resources automatically with Azure. Now, when you see automatically, remember there will be some procedure, some steps being conducted at the back end. So for that, we have to understand what is Azure Autoscale, like what possible functionality Azure will provide for autoscaling. Well, Azure Autoscale is in itself a very powerful functionality that adjusts the capacity of your resources automatically. I know it is based on demand. For example, it can scale your virtual machine instances or containers or even app services or Azure functions, right? It can actually scale up or down your resources according to the demand in real time. For that, it may require, not actually it may, it will require almost a real-time matrix or the performance data of your environment. That can be your CPU usage or the memory usage or maybe the incoming request threshold and many more. Now, to automate your scaling, you define scaling rules. Without rules, Azure cannot understand that when to actually scale up or scale down, or maybe scale out or scale in. These rules are there to define a proper sequence, a proper trigger when the scaling must happen. So here the administrator or you will define the scaling rule based on a specific matrix. For instance, if CPU usage exceeds a certain threshold, you can automatically scale up resources. Or if the load decreases in the future, then the system can scale down to save on some money. Remember, you pay for what you use. When you need performance, scale up or scale out. When you want to save money and the performance requirement is not that high, scale down or scale in to save money. Now, when I say scale out or scale in, scale up or scale down, you can almost like sense that there are two different directions. And that is right, horizontal and vertical. We'll talk about that now. Horizontal versus vertical scaling. The concept is super simple. Let's first talk about horizontal scaling, that is scale out, scale in. This method involves adding or removing instances of your resource. For example, scaling out means adding more machines or VMs to meet your demand. And scaling in means removing unnecessary machines to reduce the cost. This will be done according to your rule and some triggers. And then, what is vertical scaling? Well, vertical scaling means scaling up or scaling down is the procedure in which you increase or decrease the size or the performance of the resource itself. For example, you can upgrade a VM to a higher tier or reduce it to a smaller size when the demand goes down. Increasing or reducing the size means adding more CPU cores or adding more RAM to your machine. This means scaling up. Now, removing the cores, removing extra RAM from your machine, you are trying to make it weaker. Basically, you are scaling down. Now, Azure Monitor also actually plays a crucial role here. Although it's a different service, but the pipeline or the integration is there. Here, this crucial role in tracking performance data, like that is metrics, and trigger your scaling actions. So, Azure Monitor plays a crucial role to track your matrix, means performance data, and also to start or to trigger scaling actions. With Azure Monitor, you can set thresholds for when to scale or when not to, or when to scale down as well. And this can be done at real time. I know that there might be some lag, but this is almost real time monitoring. Now let's move to the next concept, that is load balancing resources for better performance and achieving high availability. Now remember, load balancing, which actually works in tandem with scaling to optimize your performance and assure high availability. They go both like hand in hand. They complement each other, scaling and load balancing. Now, for that, first you have to configure auto scaling for virtual machine and other resources. And to achieve that, there is a service called Azure VM Scale Set or VMSS. Now, VMSS, virtual machine scale sets, are super critical and essential. And this option is actually really easy to implement. Basically, they allow you to automatically scale the number of VMs instances up or down, depending on the demand. This helps to ensure that your application, which is running on the VM, have the resources they need. Now, this can be done without over provisioning. So there is a sweet balance between how much you want to scale and the quantity, means the number of VM instances which you are going to create will be enough to give you a better performance. So if the situation need to scale up by 10 machines, you don't have to configure a system which will scale up to 100 machines. That is over provisioning. This need to be configured properly by the administrator first. So if the rules are all set, virtual machine scale set are awesome. Now, you can define scaling rules based on many key metrics. Now, when we talk about metrics, some of the key metrics can be CPU usage. Well, it simply means scaling up or down if the CPU usage is high or low. If it is high, scale up. If it is going down, then start scaling down, removing the resources. The next trigger can be your memory usage. Well, here you can trigger scaling action based on memory or RAM utilization. If you want to set up a custom matrix, you can also set without any issues. Like you can set a custom matrix which specify what condition needs to be met to scale up or down, like number of incoming requests or the demand of a certain application or resource. These are some examples of the matrix which you have to configure, and you have to set up the threshold so that the scaling can actually happen in the future. Now, set instance limits. Well, when configuring your VMSS, virtual machine scale set, you can set minimum and maximum instance count, kind of like a hard cap. This will actually ensure that even if the demand spikes, the system won't scale beyond a certain point. And it won't scale down too far during a low demand, ensuring a balance of availability and cost saving. So it's a hard cap which you decide while configuring all this. The next one is autoscale for other resources. Well, Autoscaling isn't just limited to VMs. You can enable autoscaling for other services like Azure App Service, Azure Functions, and even databases. Now, most of the services can be running at the back end, but it doesn't matter. Autoscaling functionality can be applied to many things, even AVD, Azure Virtual Desktop. This flexibility actually allows you to ensure that optimal resource usage is there for all types of application, optimizing both performance and cost efficiency. You are almost trying to hit the sweet balance between performance and cost. Now let's go to the lab and check how can we implement this functionality of scaling and balancing the load. I'm sure that when you will see it on the Azure portal, you will understand more. So let's go to our lab.
All right, now let's talk about scaling, especially resource scaling. The scaling can be done in both directions, vertical and horizontal. Now, when we talk about vertical scaling, then we can also refer it as scaling up or scaling down. In vertical scaling, we actually increase the capability of the single entity, such as your laptop. If you add more RAM to your laptop, or let's say you increase the hard drive space, or you just change certain component in your laptop to make it more powerful, you are basically scaling up. And if you remove the resources from your laptop, you are basically scaling down. And then there is horizontal scaling. In horizontal scaling, instead of increasing the performance of one machine, you are actually just implementing more elements to it. For example, if you have a system with a specific resources, you can actually buy more systems just like that and then balance your load. So we will see both concepts. To see that concept in action, I have to create a resource. And I will go with virtual machine scale set. For that, I need a resource group. I have one. And I also need a virtual network that also I have one. And now we can deploy a virtual machine scale set. So I will just click on create, select my subscription and select the resource group I created and give this scale set a name. I will just call it Demo VMSS. Demo Virtual Machine Scale Set. Now, I'm going to deploy this scale set as close as possible to me. That is kind of central. Availability not required for this scale set. Now, the orchestration. Basically, if you want a mix and match of your virtual machines, you can select flexible. But let's say you have a specific standardized set of machines which are all running the same resource and they also have the same resource allocated to them. You can go with uniform. I will select flexible. For security, I will just select standard. Now, this is where we have to focus. The scaling mode. Microsoft do offer us different ways to actually scale our infrastructure. The first one is manually update the capacity. Basically, whenever the administrator wants to change the capacity, that administrator will actually log in, go to the VMSS, and then manually increase or decrease the number of machines. The next one is auto scaling, which we will use. This is actually the more complex one compared to others. Over here, according to a set rule, which we will configure later, Azure will determine that, hey, after a specific trigger, should I add more resources? Should I add more VMs or not? So over here, the machine will add or remove machines according to a set parameter. The next one is no scaling profile. This is very simple and I will say more manual method even compared to this one. Over here, Azure will not create any new instance for you. You actually have to deploy your own machines and then put it inside the VMSS. So you are manually attaching the machines with this pool. So we'll go with auto scaling to check the benefit. This is the most advanced way to actually use this service. Now, when I use this, I have to configure the scaling configuration. By the way, Azure already do offer a default condition. If you want to use that, then you can just go ahead and save it. Or if you want to edit it, you can also do that. Over here, I will click on the edit button and I will say, yes, I want auto scaling. Let's start with only one machine. That is default instance count, one. Instance limit. The minimum count of instances this condition will scale down to. So if you are starting with one, then I will go down to one machine. This is the upper limit. Maximum, I just need two to just prove the concept. Now, when do you want to scale out? CPU threshold greater than. If the CPU is like greater than 80%, then scale out. All right. When this trigger will actually occur, how many machines or how many instances you want to create? If you want one by one increments, I can select one. But if you say two, that means when the trigger occurs, two instances will be created at the same time. I will say one. Scale in. When the CPU threshold means the CPU utilization drops below 20%, then start removing the instance one by one. So basically, this is scale out and this is scale in. So, what kind of scaling this is? This is horizontal scaling. We will talk about vertical scaling later. Now, what is this? This is very important, actually. Machines do sometime actually have spikes in the utilization, which means sometime computer goes to 100% utilization for a brief period of time, maybe like for a few seconds. You don't want Azure to start creating new instances for every spike. So over here, Azure will make sure to actually take an average of the last 5 minutes of activity. And if the machine is above 100 or 80% in our case, for more than this 5 minutes, only then a new instance will be created. So this is kind of a buffer to make sure that the spikes are actually controlled in a good manner. So I'm happy with this configuration. So now we can go ahead and save it. Now, which operating system you want to actually deploy on your machine? For the ease of it, I'm just going for Windows 10. You can also do Windows 11, it's up to you. Now, what will be the size? This is where you can decide your scaling vertical implementation. Basically, I'm starting with DS1 V2, which gives me one virtual CPU, 3.5 GB RAM or gigabits of RAM. For my use case, this is enough for demo. What will be the local account? So local admin account will be admin and a generic password for the demo usage. Next, for Spot, we don't need any Spot registration. We don't want any discounts. This is just a demo. So I'm going ahead. For disk, I'm just going to use standard hard drive to make it a little cheaper. For networking, I will use my network. I have one network called VNet01, so I will put this machine inside this network, and this will be the subnet. Next is management. We don't want any management here, so I will just say manual is fine. We don't even need auto updates. This is just a demo. Once I will show you the demo, I will delete this infrastructure. Boot diagnostics. We are not going to monitor anything right now. So disable it. Because for this demo, I'm just going to show you what scaling actually means. So I'm leaving everything else. So health, I don't want to monitor it. Advanced, max spreading is fine. Tags, I will add my tag. And let's create this. So this is how you create a simple virtual machine scale set. Now, once this is deployed, I will actually connect with the machine and then we will run a benchmark. We will run the benchmark just to push this machine to the limits. And we will wait for some time. After that brief period of time, that is 5 minutes, we will come back to Azure portal and we will see if new instances are created or not. If everything goes by the plan, new instances must be deployed by Azure. All right, so it is deployed now. Let's go back and check the machine. So over here, the deployment was successful. If I go to instances, I only have one machine that is running. So if scaling concept is actually true, then we should be able to push this machine hard, and then we will come back and see another instance over here. It should automatically be generated by Azure. So let me now connect with this machine. So I'm actually going to connect with that VM inside my sandbox. So I will put the credentials here. All right. Now in this machine, I will just run a benchmark. Basically, I just want to push the CPU to 100%. So let me just log in properly and I will run the benchmark. All right, so I'm just going to push the CPU. So as you can see, the CPU is at 100%. So if we go back to Azure, we'll go back to our scale set and go back to instance. We have to wait for the trigger time. Remember, 5 minutes? So we will come back after 5 minutes and see if a new machine is deployed. All right, as you can see, 5 minutes and 13 seconds. It's about time. Let's go back. And here we go. We have another computer. This is just another instance. So this is what scaling is all about. But in this case, we learned scaling out, horizontal scaling. Now, what about scaling up or vertical scaling? Basically, for that, you have to change the resource of the instance itself. So if you go under availability and scale, you will see an option called size. Click on that. This is where you can actually increase the resource as per the instance, like for every instance. We were using DS1V2. That gives us one CPU, 3.5 GB RAM, and so on. And also a quite normal IOPS, that is 3200. And this will be the price per month. So if you want more, yes, you can scale up. You can choose D8SV3, which gives you 8 CPUs, 32 GB RAM. Plus, there are other sizes as well. It all depends on the requirement. So if you want to change this, all you have to do is click on the size you need and then click on resize. So after clicking resize, your machine will be scaled vertically as well. So that was scaling for you guys. All right, now let's talk about load balancing. In the previous demo, we saw that the scaling can actually work automatically, or you can also manually scale up or down, even scale out and scale in. But there is a problem. If you see the instances, I have two running. So if I go here, And I click on the machine and I go to public IP that is 4.206.14.178. So that is the public IP of the first machine. But if we move back to another instance, the IP changed. So if you want to connect with your machine, let's say in the future there are 10 machines deployed, it will scale out, right? Every machine will have a different IP. Will your users or customers connect with your machine separately? No. It only makes sense that if these machines are trying to uh, run a service which is actually standardized, then there should be a common point of ingress and egress. Means there should be a common point of connect. That is why we will deploy a load balancer in front of it. The load balancer will distribute the traffic among all the instances at the backend dynamically. So now let's deploy a load balancer. So for that, find or search for load balancer. You can also use the short form LB, load balancer. And right now, I don't have any load balancer in front, so let me create one. So click on create and then select your resource group and give this load balancer a name. I'll just call it demo LB. It will be in Canada Central. And for the performance, for the SKU, stock keeping unit, I will just use standard. That is good enough for our demonstration. Now, what type of load balancer you want? I want it to be public so that the people from like public domain can connect with it. And in this example, your machine at the backend may be running your website. All right, those machine can be a web instance. Click next. Every load balancer need a front end IP. This is the point of inbound outbound traffic from public domain. So I will just add a front end IP that will be a public IP. I'll call it demo pub IP. It will be IP4. Do I have the IP address? No. Remember, these two IP addresses are assigned to those machines. I know those machines do not need any IP address anymore. I can even remove these IP address and then assign the IP address to the load balancer because the machines will sit in the back-end pool and will only use the private IP address. I think I should do that first. So let me remove all public IP. The machines do not need 2 point of entries, correct? So let me just remove the public IPs. All right, so now let's create a new public IP for this load balancer. I will just call it public IP load balancer. Do I need redundancy? No. I'll just say no availability required. And that's it. Now I have a public IP. Next, do I need a backend pool? Of course, I have to put my machine inside this pool. So I will just call this pool as demo pool. And let's connect with our virtual machine. My virtual machines are inside network 1. And you have to add the machines here. So I will just click on add. Now pay attention. You get the option for selecting the virtual machine or the virtual machine scale set. Well, you can put whatever you want, but there is actually a difference here. In this case, we should select virtual machine scale set because if you select these two machines, if there are extra machines deployed by the scale set, you will not get those machines in your pool. Plus, if this machine is removed by the scale set, because scale set can remove this. Remember, if this machine have no load on top of it, this machine will be removed. Then your pool will lose one machine. So it's better to select the scale set. Now, if you select the scale set, the backend pool can expand and contract automatically for you. So I will do that and click add and save. So I have a front-end IP, I have a backend pool. Next, you have to create a load balancing rule. So I'll click on it and I will just call it LBR, load balancer rule. Now, what's the rule? All the requests coming from this front end IP will go to which backend pool? This backend pool which we created. The protocol for the request will be TCP, and the request will come from a specific port. In our case, I will select 80 because I will also deploy a web server on our machine. So let it be port 80, and the backend port will be 80 itself because I'm not using any certificates, so don't worry about HTTPS traffic. For the demo, HTTP traffic is good enough. So this means the request will come from port 80. It should go to port 80 at the backend. Now there must be a health probe to check the health of the service. So we have to create one. I will call it demo health probe. Now the health probe will check HTTP traffic on port 80 and save it. Rest, you don't have to do anything else. This is just extra services if you want your session to be persistent. If the connection drops, maybe for bad network or the customer is in a tunnel or somewhere, the session will still remember the connection, and when the customer comes back or the user comes back, the user will get the same instance. But these are all advanced options. Save it. So now my load balancing rule is ready. Do we need any natting? No. Do we need any outbound rule? No, nothing is going out. The request will come in. Add your tag. Click next. And I will just deploy it. All right, as you can see, deployment is done. Now we can go to the load balancer, click on the load balancer, and then I will click on settings. I just want to show you the front-end IP. So here you go. This is your new front-end IP. So all the requests will come through this IP now. All right, so now let's test it. I will go to my load balancer and get my public IP. In the meantime, I turned on my web IIS feature on my machine. So my machines are now acting like a web server. So this is my sandbox. And let's go to that IP address. Remember, this is the IP address of the load balancer. And here we go. So our website is working on the machine. Now in the future, let's say the traffic is too high and this machine cannot handle all the traffic. What will happen? First of all, according to the rule, the VMSS, virtual machine scale set, will scale out. It will deploy another machine. And then in the load balancer backend pool, there will be two machines. So some will go to the machine 1 and some request will go to the machine 2. This is how scale set and load balancer work together. So that was your load balancer, guys.
Welcome back. I hope the lab was easy. Now you know what scaling really means, and also how load balancing can actually complement your scaling infrastructure. So let's summarize this episode. To wrap up, here we covered multiple functionalities. I will start with Azure Autoscale, which actually lets you automatically scale your resources based on almost real-time metrics, such as CPU usage, memory, or you can even create custom metrics. Now, we also understood horizontal scaling, which adds or removes instances, and vertical scaling, which actually adjusts the size or the performance of the same instance. And how Azure Monitor integrates with Autoscale to trigger scaling actions based on performance data or metrics. Load balancing also complements scaling by distributing the traffic evenly across instances in the backend pool, improving performance and availability. Well, VM scale set ensure that you have the right number of VMs based on the demand, while you can actually set instance limit to avoid over provisioning or overscaling. Well, auto scaling applies to other Azure resources like Azure App Service, Azure Functions, database, and many more services like that. Why? Of course, to optimize both performance and cost. By implementing scaling and load balancing together, you ensure that your Azure resources are cost effective, very responsive, and highly available, providing a smooth and scalable experience for the end user. Thanks for joining this episode, and we'll see you in the next episode. Take care.